Philosophy ranks Thales as the foremost among the 7 sages of ancient Greece, a man honored as the father of science. Thales once firmly stated, "All things originate from water. Water is the source of the world." Each of the 7 Greek sages left behind a maxim, and Thales' saying was, "Water is best." Meanwhile, Lao Tzu said, "The highest virtue is like water. Water benefits all things and does not contend. It resides in places that others disdain. Therefore, it is close to the Tao." This means the noblest quality is like water. It embraces all things without striving, without having petty awareness chasing short-term gains. It reaches a level of mind and spirit that is the gentlest yet strong enough to contain the world. In Taoist philosophy, water represents supreme goodness and supreme softness, the kindest, the most pliant. The nature of water is precise. When small, it is still. When vast, it surges powerfully. It does not compete with the world, yet it embraces everything. Have you ever wondered why water makes up 70% of the human body's weight? Why can humans survive many days without food, but cannot live without water? Have you ever wondered what would happen to Earth if ice didn't float on water? Why is it that no 2 snowflakes on Earth are ever exactly alike? And why does each drop of water seem to reflect an entire world within? Water is one of the most familiar substances to us, yet have we perhaps missed so much because we don't truly understand it? A recent study by the Aerospace Institute at the University of Stuttgart in Germany claims that water has memory, and this claim could very well change our entire perception of the world. So what exactly does this mean? Could this be the reason why ancient philosophers believed that water is the origin of all things? For everything in existence, water is the most fundamental element. Up to now, human intelligence has been gradually expanding, and our understanding of water is making great leaps forward as well. Today, let's talk about the memory of water. Although water is incredibly common, in truth, we barely understand it. There are many water-related phenomena that science still cannot fully explain to this day. For example, we all know that water freezes into ice at 0 degrees Celsius. However, there is a very rare phenomenon that people may not notice, and that is, the volume of ice is greater than the volume of water. Normally, when a gas turns into a liquid and then into a solid, the volume continuously decreases, meaning the density keeps increasing. But water is not like other substances. When it changes from a liquid to a solid, its volume increases instead, and its density decreases. That's why ice floats on water. And it is precisely because of this property of water that all life on Earth was saved. Why do we say that? In the past, we've talked about how Earth went through many ice ages. During those times, the planet became extremely cold, and the entire Earth turned into a frozen sphere. So why didn't all animals freeze to death? That's because, as soon as it got cold, water on the surface of Earth immediately froze and formed a layer of ice. This ice layer blocked the cold air outside from reaching the water underneath, preventing the water's temperature from dropping further. Moreover, sunlight can pass through the ice layer into the water, helping to keep the inside warm. And thus, sea creatures and freshwater organisms can continue to survive in it. But if ice were heavier than water, it would immediately sink to the bottom as soon as it froze. Every time water froze, the ice would sink, eventually freezing all the water completely, and everything would be frozen solid within it. In addition, the freezing point of water is not fixed. Under normal conditions, water freezes at 0 degrees Celsius. But when freezing occurs slowly, it no longer freezes at exactly 0 degrees Celsius. Instead, it can freeze at temperatures below 0 degrees Celsius. This means that water can remain liquid even at -10 degrees Celsius to -20 degrees Celsius. This kind of water is called supercooled water. Currently, the lowest temperature at which water can freeze slowly is -48 degrees Celsius. That means, as long as the temperature is above -48 degrees Celsius, it's still possible for water to remain in liquid form. Only when the temperature drops below -48 degrees Celsius will it definitely freeze. At that point, it has nothing to do with freezing speed anymore. Why this happens is still unknown to this day. Moreover, ice formed under such low temperatures is not like ordinary ice. It may look like regular ice, but in fact, the molecular structure inside is extremely chaotic. Typically, the molecular structure of solids is highly ordered. From a definitional standpoint, some forms of matter that appear solid may actually fall under the liquid state. However, visually they look solid. So are they solid or liquid? To this day, science has yet to provide a definitive answer. Researchers at Stockholm University, Sweden, conducted experiments and discovered that water is actually composed of two different liquid types. Neither of these is truly water as we know it, and their nature remains unknown. They also cannot be separated. In 2017, a study by Oxford University, UK, revealed that water undergoes a qualitative change between 40 degrees Celsius and 60 degrees Celsius, meaning water below 40 degrees Celsius and above 60 degrees Celsius are not the same substance. Another major mystery is the origin of Earth's water. To this day, it remains unanswered. The academic community is split. One theory suggests that Earth was born with water. If Earth had life from the beginning, and life needs water, then perhaps our planet carried water with it from its formation. However, this idea conflicts with the widely accepted theory of how Earth formed. Currently, Earth is believed to have formed from a massive explosion, arising within the solar system and eventually giving birth to all existing planets. The planets closer to the Sun are primarily rocky, while those farther away are mostly made of gas. Thus, Mercury, Venus, Earth, and Mars are all rocky planets, but among them only Earth has water, which is truly strange. To this day, the origin of Earth's water remains a mystery with no definitive answer. There is also a fascinating phenomenon you've probably heard of. No two snowflakes in the world are exactly alike. So how do we know this? The earliest known snowflake researcher was Wilson Bentley, born in 1865. At age 15, his family gifted him a microscope. The first time he saw a snowflake through it, Bentley was instantly mesmerized. From that moment until his death, he dedicated all 51 years of his life to one mission: photographing snowflakes. He captured more than 5,300 snowflake images and found that no two were ever the same. In the 1880s, cameras at the time were extremely complex and difficult to use. Yet he managed to photograph snowflakes through a microscope. That was truly remarkable. After capturing over 5,000 non-identical images, Wilson named each snowflake individually. And it was only then that the scientific community began to take notice of his discovery for the first time. Previously, no one paid attention to this issue. It turns out that no two snowflakes are the same. Water is truly a remarkable substance. In the video, The Apple That Doesn't Rot, Kimura's Orchard, we also mentioned the research of Japanese scientist Dr. Masaru Emoto on water crystals. What's fascinating is that his groundbreaking research was inspired by the phenomenon that no two snowflakes are exactly alike, as mentioned earlier. In everyday life, when you meet someone fluent in two languages, you'd probably praise them as highly intelligent. Yet according to Dr. Emoto's findings, water can also read written words in various languages, and even express meaning through the formation of its crystals. Since 1994, Dr. Emoto has used high-speed photography in freezing conditions to observe how water crystals form. He used the same water in different bottles, attaching pieces of paper with different words written on them, facing inward, allowing the water to read them. The results showed that the word "thank you" caused the water to form stunning hexagonal crystals. When "thank you" was written in different languages, the water responded with unique crystalline forms, all of them beautifully symmetrical and deeply moving. In contrast, when curses like "you fool" or "you idiot" were written in various languages, the water failed to crystallize. Most strikingly, when exposed to the phrase "I'll kill you in a rage," the crystal pattern resembled a bullied child, chaotic and unsettling. When shown the word "wisdom" in Japanese, English, and German, the water formed neat, well-defined hexagonal crystals. With the word "angel," it revealed a glowing, radiant pattern, a small, delicate, crystalline halo. But when presented with the word "demon," the center of the crystal appeared as a dark, raised bump, radiating aggression. Dr. Emoto also conducted a powerful second experiment. He placed cooked rice into 3 glass jars, each filled with water. Every day for a month, he said, "Thank you" to the first jar, "You're stupid" to the second, and completely ignored the third. After 1 month, the rice in the first jar fermented and gave off a pleasant aroma. The rice in the second jar turned completely black. The ignored jar developed mold. Professor Emoto believed that his experiment revealed a profoundly important lesson, especially in how we treat children. Indifference and emotional neglect, he said, are among the most harmful actions. We should give children more care, attention, and meaningful interaction. While this may not be easy to maintain consistently, the effects are always evident. In a recent study on water droplet structures, Professor Bernd Croplin from the Institute of Aerospace at the University of Stuttgart, Germany, discovered something extraordinary. Within each drop of water lies a beautifully unique visual world. No 2 droplets are alike. Each has its own distinct shape and posture, astonishing researchers. Why is that? Science suggests that it's because each droplet carries different information. Just like humans, water can remember the things it has come into contact with and reflect those experiences visually. To test this, scientists placed a flower into a glass of water for a short time, then removed it. They found that the water retained the flower's image, and this image could be seen within every individual droplet taken from the glass. If a different flower is used for the experiment, the results remain consistent. For example, when using an American carnation, the image that appears in the water clearly resembles that specific flower. This led to a controversial conclusion. Water has memory. However, gaining recognition for this idea has been a long and difficult journey, one that requires a major shift in scientific thinking and, in some cases, even personal sacrifice. In 2009, a groundbreaking paper was presented by Luc Montagnier, a French virologist and Nobel laureate in medicine, 2008. In his study, he introduced a startling discovery. He claimed that when a DNA solution is diluted to the point of near purity, theoretically containing no actual DNA molecules, the properties of the DNA still remain in the water. It was as if the water had remembered the DNA that once touched it. Even more surprisingly, those properties could be transferred remotely to another sample of pure water. In other words, water not only possesses memory, it may also have a form of teleportation ability. This phenomenon was referred to in scientific terms as DNA teleportation. However, this idea proved difficult for the academic world to accept. After Montagnier's paper was published, the scientific community was in an uproar. Many dismissed it as a fairy tale, too fantastical, too unbelievable. Still, Montagnier insisted he had been working on this research since 2005. He claimed the experiments were repeatable, the results verifiable, and the paper itself reliable. In 2010, at a Nobel laureate conference held in Germany, Montagnier once again presented his findings. The event was attended by 60 Nobel Prize winners and over 700 scientists. Yet most attendees shook their heads in disbelief. Some even criticized him harshly, accusing him of supporting homeopathy, a controversial treatment based on extreme dilution, often dismissed as unscientific. The backlash was so intense that Montagnier lost his research funding and was forced to leave his home country to continue his work abroad. Despite being a Nobel laureate, he had to start over elsewhere. Even during that year's Christmas, peace eluded him. However, despite everything, Montagnier showed no regret. On Christmas Eve, Science magazine published an interview with him. In this final interview, he finally had the chance to speak his truth. He stated that his experiment was not pseudoscience and that he was not a quack. These were real phenomena, he said, and they deserved deeper scientific exploration. In 2013, Montagnier collaborated with a television network to produce a documentary titled "We Found the Memory of Water." In the film, they faithfully recreated his original experiment. This time, the experiment went beyond just dilution. It involved electromagnetic waves. First, they prepared a sample of water that had previously contained viral DNA. After removing all physical traces, the water was serially diluted. Then, using a detection device, they identified a low-frequency electromagnetic signal. This signal was converted into a 6-second audio file and emailed to a collaborating research group in Italy. In Italy, the team played the audio continuously for 1 hour to another sample of pure distilled water. Afterward, they poured that water into a machine designed to synthesize DNA. If additional instructions were input into the system, the machine could synthesize corresponding sequences into DNA. And that's when the miracle happened. The DNA produced by the machine was 98% identical to the original DNA in Paris. In other words, through this series of precise steps, DNA from Paris was successfully replicated in Italy, and water served as the transmission medium. Not only could water listen and record, but it could also send and receive signals. Isn't that a sign that water has a soul? This marked the full conclusion of the experiment and revealed how truly wondrous water could be. However, after the documentary aired, public reaction remained largely unchanged. While no one publicly condemned it, no one praised it either. People's attitude toward Montagnier was cautious, as if out of respect for his past achievements. The man whom Montagnier once called the modern-day Galileo, Jacques Benveniste, faced even harsher consequences. A renowned French immunologist, he had served as director of France's National Institute of Health and Medical Research and published over 300 academic works in his lifetime. He was once regarded as an intellectual giant, yet all of his fame and prestige came crashing down in 1988. That year, Jacques Benveniste published a highly controversial paper in Nature, claiming that water has memory. He discovered that if human IgE antibodies were diluted to the point where no molecules should theoretically remain, essentially becoming pure water, the solution still exhibited the biological effects of the antibodies. After repeated experiments yielded the same result, Benveniste concluded that water could retain memory. The paper was seen as incredibly bold. Was he suggesting perhaps that water has a soul? The editorial team at Nature was stunned. Once they recovered, they launched an investigative task force, officially to verify the science. But in reality, their intent was to debunk a potential scientific hoax. This team conducted 3 consecutive experiments, and one member personally participated in a 4th. The result? All trials were successful. Based on these results, the team had to admit that, scientifically speaking, the phenomenon of water memory was verifiable under controlled conditions. However, since their original mission was to disprove the study, they decided to alter the experimental conditions, hoping it would invalidate the findings. For example, they imposed absurd conditions like covering the samples with aluminum foil or suspending the water samples from the ceiling. These unreasonable modifications meant the water could no longer see, hear, or be influenced in any meaningful way. After applying such restrictive measures, they hastily concluded that Benveniste's experiment was unreliable. They said, "See? Water isn't nearly as magical as he claimed." Immediately afterward, Nature published a harsh retraction, and rumors spread rapidly. In no time, Benveniste was branded a fraud within the scientific community. His reputation plummeted, his lab was shut down, his research funding revoked, and he became the subject of ridicule, some even calling him the most embarrassing Nobel-associated scientist. No journal would publish his work anymore. In modern terms, it was as if Benveniste had been permanently deplatformed. However, despite the backlash, many independent scholars, even those who hadn't witnessed the experiments themselves, came forward and demanded justice for Benveniste. Some argued that out of 7 experiments, only 3 failed, and those failures were due to unjustified procedural changes, not fraud. Others pointed out that several independent labs had replicated similar results. Yet before issuing its official dismissal, Nature did not reach out to those labs to verify the data. Additionally, some scholars raised the idea of the observer effect, a phenomenon often seen in quantum experiments, where the mindset or intention of the observer can influence the outcome. In short, if the review team approached the experiment with strong skepticism, that very attitude could have skewed the results. Still, despite all the backlash, Benveniste offered no defense. Nor did he abandon his research. By the 1990s, he introduced an entirely new line of thought. He believed that the memory of water could be digitized, then transmitted and embedded into another sample of water. However, at the time, almost no one could accept such an idea. It was far beyond what the scientific community was ready to comprehend. However, to this day, Montagnier's experiments have effectively confirmed that Benveniste's theory was correct. Sadly, Benveniste passed away in 2004 and never lived to see his ideas recognized and supported by later generations. If water truly has memory, wouldn't that provide a scientific foundation for homeopathy, which we mentioned earlier? First, let's briefly explore what homeopathy actually is. Conventional Western medicine sees symptoms as signs of the disease itself, so eliminating the symptoms is considered equivalent to curing the illness. According to this logic, high blood pressure must be treated with antihypertensive drugs and fever with antipyretics. This method is called the antagonistic approach. Homeopathy, on the other hand, takes the opposite route and is therefore also known as the principle of similarity. It suggests that symptoms such as coughing, fever, or diarrhea are not the root cause of illness, but rather the body's natural way of expelling the disease. For example, if someone ingests something toxic, the body reacts by vomiting or causing diarrhea to remove the toxins. In this case, the toxic substance is the actual cause of illness, and vomiting or diarrhea is the body's healing process. Based on this idea, homeopathy uses substances that would normally cause similar symptoms, but in highly diluted forms, to stimulate the body's ability to heal itself. For instance, since onions can cause watery eyes and sneezing, a remedy containing onion extract can be used to treat allergic rhinitis, whose main symptom is frequent sneezing. However, most medicines that intensify symptoms also tend to be highly toxic. So what should be done? Samuel Hahnemann, the father of homeopathy, said it was simple. We just need to dilute the medicine. But during this process, he discovered something truly strange. When the medicine was diluted at a 1:99 ratio and placed into a glass vial, then shaken vigorously 100 times, its toxicity was removed, yet its therapeutic effect became even stronger. Even more astonishing, the more the solution was diluted and shaken, the more potent it became. Hahnemann recorded all his experimental results in his book, The Pure Pharmacology, which later became the foundation of modern homeopathy. This formed the basis of using ultra-diluted substances to treat illness. Some remedies are even diluted to the point that only pure water remains. According to physics, this means there is no measurable substance left, which seems to coincide perfectly with the earlier theory we discussed, that water has memory. However, this is exactly the point where mainstream scientists lose their composure, arguing that such logic implies plain water could be used to cure disease. Based on current scientific frameworks, this is something that cannot be clearly explained, and if it cannot be explained, it will not be accepted. Still, even proponents of homeopathy acknowledge that there is not yet a solid scientific basis for how it works. But that does not mean it is ineffective. Perhaps it's simply because we haven't gathered enough evidence yet. People can see that the effectiveness of homeopathy reaches 41%, while conventional medicine is at 44%, nearly the same ratio. In fact, aspirin, a widely known pain reliever and fever reducer, had been used for over 70 years before scientists discovered its mechanism of action. Yet over 2,400 years ago, our ancestors already knew how to use willow bark, which contains aspirin's active ingredient, to treat illness, even though there was no scientific theory or experimental proof at the time. It was simply used because it worked. That's why proponents of homeopathy argue, you may say that we currently haven't found a clear scientific mechanism, but you can't hastily label us as pseudoscientific. Even Jacques Benveniste, Montagnier, and Masaru Emoto, whose experiments can, to some extent, serve as indirect evidence for homeopathy, never claimed that they were proving homeopathy. They simply presented the phenomena they observed based on their research. Yet the response from the scientific community has been surprisingly harsh. So why is mainstream science so critical of homeopathy? Isn't everyone always saying that the development of science and technology must focus on innovation? And isn't the very essence of innovation about making breakthroughs? If you found this content thought-provoking and fascinating, don't forget to subscribe to the channel for more discoveries like this.